Right, so that should come up and this thing will start. So also what led me to be open to working in a research way was from being a student. While I was a student, I was also entering architectural competitions, which obliged me, because my talent wasn't sufficient, to work with others on them. So, and that meant working with engineers, service engineers, structural engineers, and civil engineers. And inevitably, that demands an interdisciplinary approach and a desire to find out more of what we were doing to differentiate ourselves, not just from looking, cool images and things like that, but actually substantiating the proposition of design that we were giving. So we designed buildings like this. This is a building for Velux, designed 20 years ago now. It still meet today's building regulations, super insulated, thermally massive, timber construction. Velux stands for ventilation and lux, light, the two means by which you start to remove energy consumption out of buildings. So we do 5 things: architecture, landscape, master planning, consultancy, research, and our business is underpinned by a sort of philosophical approach to being on the planet, something called systems thinking. Linda Farrow, a co-founder, she's not an architect, she's an industrial chemist by training, worked in the environment world, and then we decided that we should take a risk and set up a practice. And so we're slightly unusual in that regard. So systems thinking is weaving in an interconnected and interdependent world. So that's an architect's drawing of what systems thinking is, and it's complex. But it need not be complicated. Complexity is not a problem, complication is. And in the built environment, we want to be more sustainable, we want to enhance people's quality of life, we would like health and well-being to be part of being in a building, whether it be delightful to look at or simply not poisoning us with VOCs out of highly processed materials. Can we make buildings that make people feel happy? And if they are happy, are they more productive? And all of those are interconnects. They're not separate things, but we still design buildings as if they were. Somebody asked me what this is, so I put a slide. I know this is this little badge here, the colourful one. United Nations Sustainable Development Goals, of which there are 17, and they're all multicolored. And this would be the area of attention we would give when designing a building, and not simply trying to design a building from an architectural ambition point of view that would be ego-led. We also tend to measure performance in buildings using Forum for the Future's 5 capitals. And they say the economic world is concerned with 2 types, financial and manufactured. Can I make things and can I sell them, and can I sell the money I'm now making on the back of things being more valuable with future speculation? But that's only 2. We also live in a social and a human world, and can we measure those as a form of capital? There is an element of social capital established here. You have bothered to turn up. Some have to turn up, students falling asleep at the back, and others, I hope, pleased to be here. And then we have natural capital. And the key thing about this is none of the inner circles can happen unless the outer one is functioning. So every form of capital, however we choose to measure it, is a subset of the natural capital of the planet. With no natural capital, we don't even have a gathering. So, and for many, people think, well, I want to design a building and make it more sustainable. That's sort of starting at the wrong end of the pipe. You need to think about, how do I be sustainable in the way I choose to design buildings? And we measure those where we can. So we have a desire to quantify what we do, not simply from a quantity surveyor's point of view in terms of money and cost per square meter, but can we measure all of those capitals? Other people are trying to do this. Bioregional developed something called One Planet Living, and so you get a rotating planet when you do that, which basically looks at footprinting and turning it into a currency that people can understand. So footprinting started in the 1970s as a result of the oil crisis, when we took it upon ourselves to measure how much it takes of the world's resources to be able to maintain our health, well-being and happiness. And in theory, everybody gets 1.9 hectares of land. Does anybody here own 1.9 hectares of land? Some of the wealthy students at the back may have mums and dads who do that, but it's extremely unlikely because we're not equitable about the division of land. And that's not all the land available on the planet. Glaciers, even though they're melting, are not counted in that. Very, very steep mountains are not counted in that, and 2% of everything is given back to all other species on the planet. So as humans, we have decided that the rest of all life on the planet can survive on 2%. So if every man, woman and child on the planet could live as you and I are currently living in a developed Western economy, we would need more than 1.9 hectares to support that. We would need 6 hectares, or turn that into a unit of currency called the planet. We need 3 planets worth of resource to live like Europeans, i.e. 7 billion people on the planet, all living like Europeans. We need to find a couple more planets. That's not going to happen, and of course we can always feel a lot better by looking at America, who require, an American individual needs a 12 hectare footprint or 6 planets worth of resource. So if we all live like Americans, we are screwed. If we all live like Europeans, we're still relying on a lot of other people in the parts of the world that are still developing, living on a quarter planet's worth of access to resource. So we have a debt crisis environmentally. We are living in debt. So we call what we try to do is called research into practice. So research, we do practice, we teach, learn, rinse and repeat. And I'm going to talk about how we do that. And so we're not doing research on ourselves, we're trying to find out how research can help us do better. So a slightly different approach. So I'm going to do this in terms of 2 big issues for us. We live in a time of crises. There's Trump, there's Brexit, but let's just only worry about climate change and housing in this talk. So climate change. That's the 5 carbon sinks on the planet, and it turns out that the naked ape, when it discovered oil would burn and coal would burn, we release carbon dioxide. Nature had been doing that quite happily on a big cyclical basis, but what we're doing is putting more carbon dioxide into the system than nature would otherwise do, and we put that into one of the large carbon sinks, which is the atmosphere, and that changes the TOG value of our atmospheric duvet, and that warms up, and that causes untoward weather events. Then there's oceans, the biggest carbon sink, but too much carbon dioxide in the ocean turns it more acidic, and acidic is not good for quite a lot of the life in that. Then we have ancient carbon sinking, which is limestone, basically dead phytoplankton and other kind of calcium carbonate acquiring creatures that died 60 million years ago off the coast of Dorset. And then we have us, the biosphere. We are the living part of the biosphere, and then we will all end up as the dead part of the biosphere in soils and other things. So those are the 5 carbon sinks. And we ask ourselves a question: if buildings are responsible for 45% of all emissions of CO2 into the environment, shouldn't we start thinking about, could we work within the system rather than exploiting it? And a particular area of interest is the carbon cycle only exists because life exists, and life uses photosynthesis to shift that carbon around. The limestone wouldn't exist unless a phytoplankton had lived 160 million years ago in Jurassic oceans, but it relies on photosynthesis, which is the ability of life to convert sunlight into matter in the form of consuming carbon dioxide and banking that as carbon either in calcium carbonate bones for phytoplankton or in plants and trees, becoming the building blocks or complex sugars which go to make our wood and materials. So global synthesis consumes 110 billion tons of carbon, or 404 billion tons of CO2 is consumed by photosynthesis annually on the planet. That's a lot of carbon shunting going around. So could we build with carbon? So we do sunlight, water, and that's a carbon dioxide molecule. And if we looked at trees, and if we produce 1 cubic meter of timber out of a 30-year-old tree, that tree will have banked or consumed 742 kilograms of CO2, ejected the oxygen to atmosphere, and kept the carbon to make the physicality of that wood. So we then went and said, well, what else could we use? People have been using timber for a long time in construction. Can we use straw? And straw does it really quickly. For every 1 kilogram of straw, it has to have consumed 1.62 kilograms of atmospheric CO2. So we have a carbon capture system. And of course, these are just graphics, but this is all based on a lot of research work, working with the University of Bath, Timber Research and Development Association, etc. So we had some ingredients that we could start working with, and could we build a building system? So there's no fruit in what we do, but that's a proxy for limestone. So wood, yes, we can build with. Straw we can insulate, and hemp and other materials, and lime, and being limestone, we can build with carbon. So we set up a company called Mudcell, and these are buildings entirely made out of timber, straw, and lime in various degrees. Bristol, Northwest Media Centre, the Bell House at Bath, which is a research project. When we did this proposition, we went on to build Hayesfield Girls' School, a STEM centre, Nottingham University, Agricultural College, and a cafe somewhere in Hereford. And we produce a lot of, this is my RAE submission from 4 years ago, all UE logoed for the ref, but basically working with engineers, doing fire testing, doing thermal modeling. It's all organic. Water is the enemy of organic materials because nature does what it wants to do, it wants to eat it. And decay had to be dealt with. But we also did a lot of work in how we were to build things. So we developed a system of prefabrication which takes all of those raw materials, limestone and straw, as a combine harvester, and we developed a method of near-site prefabrication called a flying factory. Today, you might call that a pop-up factory, and the construction industry now call them consolidation centres. But we've got an international standard developed for doing that. We take timber, we work with local schools, labour and material, and we build buildings that are prefabricated. So here's a little kind of time-lapse film of us building the Bale House at Bath at university with the Department of Engineering as research partners. So that's day one. The slab goes down, cross-laminated timber floors. We did this about 10 years ago. Top floor goes on, and then we seal it all in, and we're weather tight in 2.5 days. Today we can do that in a day, and we build, and it ended up looking like that. But we're now, if we're building with carbon, we ought to measure it. So how much carbon is there in that building? If we get all the carbon to hang around in one big space and be blue, that's what 34 tons of atmospheric CO2 looks like, and that is what has been consumed by all of those carbon capturing materials in the building. The straw, the timber, and the lime captured that carbon 120 million years ago. And that's the equivalent of 45 years of a domestic photovoltaic array running, which is 20 years longer than a life design for PVs. So we got into carbon footprinting. We worked with Imperial College London on how we do that. So we worked out, yes, we can build with carbon, so climate change appears to be sorted. So crisis number one dealt with. Let's move on to housing. This is the map of the UK house building programme from 1923 to close to today. The big gap in the middle is the war, where nothing is happening. Green is private sector, red is public council housing. And you can see an enormous build programme. And the target at the moment is to build 300,000 homes a year. We're building half of that. But the UK has built substantially higher numbers, peaking at 350,000 houses in the late 50s, early 60s. And most of that done by the public sector. If I just put that arrow on, that is Margaret Thatcher cancelling the council building programme in the UK and then relying on something called housing associations to fill the gap. And you can see it hasn't done it. Definitely not done it. So, the housing is the most expensive it has ever been. I could not afford to buy the house I currently own if I were to try to buy it today. I have no idea how my son will afford to do that. And in Bristol, the average income houses, so in 1997, the average cost of a house was 3.6 times the Bristol average income. Today it's 8.2. If you go to London, it's 14.6. So there is no means of anybody graduating out of this university buying a home in London. And in fact, graduate architects are now earning officially below the low wage, earning threshold in London. So 6 or 7 years of elite education, you're a low wage earner officially in London. And you will never buy a home unless mummy and daddy are very wealthy or you win the lottery. So this is a crisis because we designed a system that relies on people owning homes. Our pensions are linked to home ownership. It's the means by which the baby boomers got onto the up escalator of capital acquisition. Promise was work hard, study hard, get a job, take out a pension, buy a home, retire, downsize a bit and retire into a civil life and then die, making room for others to follow you up the up escalator. Well, the up escalator, like many, doesn't work. It's stopped. And at best it's a travelator, and for a huge proportion now of people, it's a down escalator. There is no access to capital if that's something you want to do. And the UK government starts looking abroad and says, okay, well, why don't we build our own homes? Why don't you get people to build? So if you're in Austria, 84% of all homes in Austria are built by individuals or groups of people acting collectively. 84% of all the housing in Austria. And that's a population of 70 million people. And then you see UK is the poorest performing. So could we scale people building their own homes? So we've got a double supply. That means there's a requirement to create a brand new £40 billion housing market. So that's the biggest business opportunity facing architects anywhere, not only in the UK but across Europe. And the government started something called Custom Building 2016. Then let's go back, we did some research on Bale House and we started building houses and we worked with a co-housing group. So this is now a group of people now acting collectively and willing to pool their resources to build their own home. And this is what it looks like. And it's got a SUD scheme, so it's got a pond in the middle of it. It's a community-owned solar, hot water and PV array. And these are those people. The key thing here is they pay 90% less for their energy compared to the average for Leeds. So compared to the neighbours all around them, they're about 90% less. And they built their homes for 20% less than the market would have supplied to them. So that's an interesting thing. So acting collectively allows you to apparently discount development by 20%. And basically all that is if a commercial developer had done that, that's what the developer would have walked away with. That's what every developer has to tell the bank they will make is a 20% margin. So by being the developer themselves, they have reduced that. So that opens up a whole new way of thinking about the financial mechanisms by which housing can be delivered. And so working with the New Economics Foundation and Lilac, this is the model for something called mutual home ownership, and this was the first of its type in the UK, and basically that's the financial flow of people acting collectively and servicing one debt, not 20 mortgages. So what we have is a slightly modified way of acquiring capital by acting collectively. So we're working with kind of economists at this point. I'm way outside. I'm a tourist in this area. I'm not financially trained whatsoever. And so then we go back to do some more research. We've been involved in 5 major European research projects. These are 3. Eurocell, that's looking at building with renewable materials. EcoC is looking at health and well-being using natural materials, and IsoBio is trying to develop new materials. So we're back into the research, building on what we've learnt out of working with those materials and building those homes. And we do stuff like this. We make inedible muesli bars out of all sorts of interesting materials like hemp, coconut shells, and things like that, in the ambition to turn it into something better. So we then set up a company called Cubio Circular Materials, because we were able to acquire a technology that takes straw and squeezes it into a board that can support structurally. So we've gone from straw as a bale now as an insulation material, into straw as a structural sheathing board. And so that's 60 millimeters thick, supported at 800 centers, no screws, so simply supported in engineering terms, and that's a 1.6 ton Audi sitting on it, and it's not deflecting. That then allowed us to get rid of a whole pile of timber, and we then said, well, okay, so what does this allow to do? We now need to go and do some more research on thermal modeling, because we can now do timber cladding, we can now do compressed straw board sheathing, we can insulate with straw, we can lime with straw, and we can get rid of plasterboard as well, because we can make thin compressed straw board. And so we went back to, this is some of the outputs of the EcoC research, which was to certify a build system using the passive house. And the nice thing about passive house is all the lovely rainbow colored diagrams you get, and working with very, very precise Germans to certify this, to ensure that we're using the least amount of energy to create the most comfortable space in which we can live. We then went back with that and started working with Igloo Regeneration, a developer, on this custom build world, and we developed one of these house types. These are 5 other suppliers plus us, and we developed something called Bale House, which is an off-the-shelf passive house customized solution. So to do that, we're now having to make sure we can certify with the banks for high street mortgages. So we went through a process of certification, and you can now get high street mortgages for straw buildings. But if we now go back to housing, housing is just kind of hardware. Anybody can build buildings. It's not hard to do. And if we call people software, what's apparently missing is any kind of operating system for people to engage in the delivery of their own homes. It's either missing, it's confused, not defined, or way too slow. So we worked with the founders of Lilac, in particular Paul Chatterton, who's Professor of Urban Futures at Leeds University, to create a red book, because we're now owning the means of production ourselves, slightly Marxist referencing there, to create a toolkit for community-led development that doesn't require people to have to invent that all over again for themselves. And then we come back into teaching. So I'm fortunate enough to hold a teaching position here, which is a postgraduate course on the MArch, running one of the units called the Sustainability Units, which we actually call Live, Work, Make. And it asks some questions. Where should we live? That's a housing question. We're all changing our mode. We can't promise straight line careers for graduates out of architecture schools. I think the only straight line career left is probably lawyers, but they're being hunted down by blockchain and things like that. That's scaring them, which is quite nice. And then what will we make? Well, it turns out in the intervening period, we've developed all new fantastic technologies which students are taking advantage of: laser cutters, CNCs, additive, all sorts of processes. And the idea that actually making might come back into the hands of individuals or small groups rather than corporate entities is real and can be done. So we set a program to go and ask some questions in Knoll West, which is 5,000 council houses built pre-war. And the question we proposed to the students at that time: if the community can be the developer, can the community be the bank, the finance, the legal, everything that it needs to do to develop its own homes? And the answer was yes. And we looked at land tenures, about housing variation, about house types, and how we might develop profit as a community dividend. And the students mapped the whole of the estate and found that the hardware mismatched the people. 74% of the houses are 3-bedroom homes. 54% of those homes are lived in by either 1 or 2 people. So there was this kind of mismatch of need, and that's because there is something called simultaneous aging going on in Knoll West, in that it is a new town type model, and then everybody is kind of following a wave of aging, which means there's lots of elderly people living. So the question was, and it's a garden city estate, a density of 25 houses per hectare, which is about half what we were built today. So we said, could we find space? And the answer was yes, we could. We could use what we're styling urban acupuncture to slot in 1 and 2 bedroom houses, which is the need for the estate. And there's room for over 2,000 of those, which freaks the planners out, but the plan is to build up to 500. This is a financial flow model done by Jamie, who was a graduate from last year, on how an architect could try to understand modeling the financial flow of the community being the developer, where the financial flows were capital flows and included land, time, money, and space in order to deliver an affordable housing model. And it was a big beast. First time we ever presented spreadsheets to external examiners at our review. Development is a 3-layer cake. Basically, any developer has to do 3 things: buy some land, build some homes, and sell it. And land is scarce. Landowners want maximum amount of money. Hardware, that's not a variable. It's generally a fixed cost, and sales vary by postcode hugely. That's the developer model. You can see they wear top hats and canes. And basically, they're not interested in doing anything other than maximizing margin, because affordability reduces margin and reduces value, because people don't like poor people, apparently, as far as estate agents are concerned. So Mark Twain said, buy land they're not making anymore. So without some way of reducing land cost, we can't do affordable homes. It's just not doable. So can we find a new land supply? Yes. And not pay for it. So we went to Knoll West and we thought really, really small. And we developed a model called We Can Make. So this is now taking the work the students did and then moving it back out into trying to do a project for real. Could we deliver housing it needs? So we spent a year working with the community, did consultation, asking them, would you be prepared to give over some of your land? And the answers came back as 90% agree this is a good idea, 73% agree it's a good idea for the street, 63% for that will put in their time, 43% will put in their money, and 36% will put in their land. We interviewed hundreds of people. We also thought, right, we need an agile way of delivering something, so we went to looking at legal ways of not getting planning permission to build quickly. And we looked at the Caravan Act, which has a 3 tests: construction, mobility, and size. And so we designed a passive house home made of that straw system you saw earlier. And all we've done is put it on a modified caravan chassis. And we built one without permission, and nor will we seek any normalizations, because it's not a home, it's a caravan, but it's not a caravan, it's a passive house, and it is a space compliant 36 square meter home. We then also did the carbon footprinting again, and that's now the amount of carbon dioxide now captured by that, which is up at 64 tons. And then we asked the mayor to come and sleep in it, in a home that had no planning permission, so at that point the planners were very concerned about the mayor approving it. And then we asked him, we're going to build 350 of these, we've got space to do it. We would like, that would help 700 people. We'll create 21 full-time jobs. It'll be a new housing platform. We'll create a national centre for come and look at what we did, and you can learn how to do it too. And we hope to scale it across the UK. We then said we want £500,000. We want you to give us leases on this land, and we want you to buy 10. And by the way, can we have some money to build a local factory? And the answer is yes. This is what the factory looks like on some derelict land. That's the factory below the land of the land. We're also using the system there's a little unit called a TAM, and we're using that to retrofit the houses that surround it. So there are two types of retrofit: light retrofit, people in occupation, loft insulation, windows and boilers. Deep retrofit is empty home, systematically retrofit the house. And the way we do that is family decants temporarily to a unit in their garden or nearby. We retrofit that, they move back, and then we roll that round through 4 houses and then put somebody in the house in housing need. So we defer the need by a year. These are some of the designs that we're doing. The interesting thing about this is the financial system for what's called a movable asset is very different to a fixed asset. So a bank lends a mortgage to build a house on foundations. You can asset finance a movable home. So you can lease hire, lease purchase, lease rent. In the same way, cars are available to people. And it's about people. So we're working with locals who are part of the design process and being enabled by this. We then also imagine we might design a funkier looking caravan, because most caravan suppliers design very ugly buildings. So that's 2 caravans joined together to create something a bit more architectural. They're very light, we can put them on roofs. And then the really fantastic thing, and this gets announced next week, is that we have been working with Nationwide Foundation, which is the Nationwide, the mortgage lender, and Power to Change, funded by Heritage Lottery funding, and we have secured £200,000 to enable the legal financial land assembly design coding digital platform and suppliers framework that would deliver that. And we are paying very expensive lawyers to demonstrate that that land is available, it can be free, and we can build homes on top of it. And that will be governance by a local community benefit society, so the ownership of that is the community. And then we will then take that red box, shrink it down, and do it in Manchester, Cardiff, Devon, and other places. And then that's our offices in town at Hamilton House, and we propose putting 13 up on the roof. Now that's exactly the same type of unit that we built in Knoll West, which would cost somebody in Knoll West £75,000. If anybody'd like to hazard a guess of how much a rooftop city centre 1-bedroom unit like that would cost, it's considerably more. So, research into practice, into teaching, into learning, a bit of student exploitation along the way, but there are 2 here now who have jobs in our office, and getting the design engine capability of a School of Architecture engaged in live projects with the intention of following through, I think is one model that schools of architecture could absolutely explore. And I'll stop talking there. Thank you.